Hey everybody, and welcome to the Daily Space Weather. I'm your host Dan, aka Smash-O-Mash, coming at ya from the Smash News Network, least busted name in news. Just bringing you the most detailed imagery of the sun and comprehensive space weather you'll find in the world, and of course, accurate forecasts. So we've got a ton of filaments, some new sunspots up here in the northwest, and some more information about all the coronal mass ejections that everybody is talking about constantly, everywhere, all day long, and misforecasting, by the way. So this is 131 plus 171 angstroms. It's great at showing solar flares. That's the 131 angstroms. And both wavelengths are great at showing plasma orienting to magnetic fields. That's what all of these magnetic field force line looking regions are. That is plasma aligning to magnetic fields. It's not magic. It's magnetism. Here we've swapped out 171 angstroms for 1600. That's ionized carbon plus ionized iron. And we've also brought up the 1700 plus 171 angstroms. 1700 angstroms is not a particular chemical spectra. 171 angstroms is ionized iron. That's great at showing sunspots, active regions, and again, plasma orienting to magnetic field lines, potential field surface lines. I should say potential field surface source lines. All right. So let's take a look at sunspots here. Again, we do have a new sunspot recently forming up here. You can see that sunspot forming. That's yesterday plus today's data. Also a little bit of umbral migration here with respect to each other in this large group that was associated with that X-class flare the other day. And some growth continuing down here also. So we've got a high likelihood of major flares, especially around the western limb. So the main flare player has been this group. Let's take a look at the colorized magnetogram. Main flare player has been this sunspot up here. So that's what's going on. That's yesterday plus today from SDO. And let's take a brief look at Crescent Earth's volcanic scene. Shivaluch is exploding, producing a 14,000-foot plume of volcanic ash over Kamchatka. Please do not pole vault the caldera. It could be unhealthful, and we need the views on YouTube. Semeru also erupting. It's a flight level 140, 14,000-foot ash plume over East Java, Indonesia. Popocatépetl exploding. Flight level 200 over central Mexico. It's a 20,000-foot ash plume. Headed down to Central America, Guatemala exploding, flight level 160. Sangay exploding in Ecuador, flight level 230. Sporadic emissions from Revenador, no indication of a flight level. Cotopaxi, flight level 230, like Sangay. So at least 3 erupting volcanoes in the South American country of Ecuador, and last but not least, sporadic emissions from Sabancaya in Peru as well. We'll also look at global seismicity. There's the past 90 days. In a convenient bar graph form. Any major quakes over the past 24 hours? Well, the answer is no. Keep in mind, any earthquake can be a foreshock, though, so we're going to go over those that are of a 5 magnitude or higher size. So, first of all, we've got this 5.0 in Turkey. That was at 1931 yesterday evening, Universal Time. And I think this was the largest quake of the past 24, this 5.7 at the South Sandwich Islands region. Also, Fiji had a 5.4 at extreme depth, nearly 550 kilometers depth for that 5.4 that came in at 2303 last night, Universal Time, 2303. Chile had a 5.3. That came in early this morning at 2:40 Universal Time. Again, let me reiterate, any earthquake can be a foreshock. So occasionally we do get forewarning in the form of an earthquake. And let's get back to space. It's where all the excitement has recently been. Has it caused a huge uptick in our channel viewership? Well, not really. Because big tech social media platforms are completely broken. That's the past 24 hours in 171 angstroms by itself. It is our house favorite wavelength. This wavelength actually inspired me a little bit to keep producing these videos. Who knew the rabbit hole would be so deep? Here we've added 193 angstroms, and we do have some well-defined coronal holes of south pole orientation down here. The 10.7 centimeter radial flux now at 167 solar flux units. Of course, it was erroneously reported yesterday at 343 solar flux units. That was because of the measurement being taken during a coronal mass ejection event. That created a completely ridiculous radial flux of 343. 167 is the current radial flux. That's the 1 year graph. You can view it yourself at solon.info. The black line is the radial flux, the red line is the sunspot number. And let's take a look at the Space Weather Enthusiast dashboard here. Now, I heard some people who are completely clueless about astrophysics forecasting a KP8 from the from the CME 2 days ago. Somebody out there forecasting a KP8 geomagnetic storm as a result of that February 17th coronal mass ejection, and I just found that hilarious. And of course, I tune into certain quote science end quote channels just for the lulz. And keep in mind, folks, our thumbnails have more legitimate information than entire channels. So anyway, this is the NOAA forecast for geomagnetic storms and unrest. Expecting some geomagnetic unrest late tonight, early tomorrow. Going briefly in the geomagnetic storm conditions, and then geomagnetic unrest into February 21st. Yeah, we'll show you why that seems ridiculous a little bit later in the video, as the CMEs were not correctly modeled, and we'll show more details on that later. But that's the NOAA forecast. If you want to look at it yourself, it is on the Space Weather Enthusiasts dashboard, part of the Space Weather Prediction Center. Next, let's take a look at geomagnetism here. Global geomagnetism chilling at KP1. And keep in mind the last geomagnetic storm that was forecast by NOAA. We said that's a CME that's going to miss Earth also, and guess what happened? It missed Earth. Anyway, KP index is currently at 1. It's geomagnetically calm conditions. And here are the last 4 hours of Earth's magnetic moment from space, modeled by the Space Weather Modeling Framework. This imagery depicts magnetohydrodynamic pressure around Crescent Earth. Yeah, Crescent Earth. NASA keeps trying to tell you that it's an oblate spheroid, but our channel keeps trying to tell you that it's crescent-shaped. Yeah, we're just trying to create a little bit of humor here, folks, as there are still people claiming that chemtrails are real, the Earth is not spherical, and other ridiculous nonsense, in addition to nonsense about space weather. But that's the last 4 hours of Earth's magnetic moment here. Quite calm, most of the pressure on the magnetotail side. Here's Earth's magnetic moment from the ground, our geospace delta B ground magnetic perturbations map. During times of geomagnetic storm conditions, this will show you the most likely places to see the aurora. Even during calm conditions, it'll show you the most likely places to see the aurora, pipeline, railway, and power grid induction, and so on. Yeah, effects from incoming space weather. Things calm here on the surface. Geospace delta B depicts changes to Earth's B field, the field that goes through the magnet, this magnet being Earth. And let's move to the real-time solar wind. Real-time solar wind here showing us zero signature of coronal mass ejection impacts. And we have been seeing a little bit of overhyping of the likelihood of major space weather events here in the past week or so. Current conditions are about 5 protons per cubic centimeter for the solar wind density, solar wind speed about 364 kilometers per second. Nothing to write home about there. It's pretty unremarkable. Next, looking at magnetic data. Now, keep in mind that this data comes from Lagrangian point 1. That's 1 million miles, about 4 lunar distances away from Earth. This is only about 20,000 miles from Earth. The GOES 16 and GOES 18 measure magnetic fields from their geosynchronous orbits. Completely different here. Don't get it confused. Obviously, look at the numbers here. Current conditions are, 104 nanotesla. At Lagrangian point 1, those spacecraft are detecting 5 nanotesla. You see that? The top pane there, 5 nanotesla is the BT. That's the total field detected at Lagrangian point 1. 104, so 20 times stronger magnetic field so close to the Earth. And a quick side note, if you think the universe is electric or that everything is electric, please take Physics 2, Electricity and Magnetism. Thanks. And let's continue on to look at the heliospheric current sheet as there is a sector boundary crossing showing up. So this is our top view ecliptic plane field plot. It is one of the most important data sets that we have in terms of being able to forecast without actually having to look around the opposite side of the sun, because the magnetic data gives away things that the sun is doing. So let's bring up the latest image here. You can see the sector boundary crossing here. Stereo A is just making it into the South Pole oriented current sheet depicted here in red. And we can expect that to arrive at Earth later today if nothing suddenly changes. North Pole current sheet depicted there in green. We are about to head back to the north. We're about to head from the north solar magnetic pole to the south solar magnetic pole, not to be confused with the rotational pole. And here's our line of sight field plot that depicts the sun's B field in blue, north solar polar field in green, south solar polar field in red. And you can see that sector boundary crossing showing up here, depicted by the B field. The latest image there, you can see here's the north magnetic pole of the sun, and here's the south magnetic pole of the sun. And let's take a look at coronal holes next. So here's our coronal hole line of sight plot. And we've got quite a few South Pole oriented coronal holes here rotating in. So check it out. So this one here, this is a North Pole coronal hole. These ones in the east and the south are South Pole. So here is our 211 angstroms wavelength. Again, this is a North Pole coronal hole. These are south. And we should see some more coronal holes up here becoming a little bit more clear in the coming days because the corona is bumpy. But that magnetic data is legit. You can expect to see coronal holes here. And also we can expect a high-speed stream from this coronal hole. So that'll be real obvious. And that can affect the propagation of coronal mass ejections. Again, we'll get to the calculation of the trajectories and so on here in just a minute. First, we've got to move to sunspots. And before we do that, let's look at another wavelength here. We've also added 335 angstroms. I would note once again, there are massive filaments and a lot of them. We counted beyond the number 13 yesterday in yesterday's daily space weather video. And some of those filaments have actually grown, I believe, since yesterday. We'll show you the imagery a little bit later. So first, our sunspot view here, and we will have a new sunspot. Does it already have a name? This group up here doesn't have a name yet, so that sunspot group will get named. That'll be 3231, that group right there. And if we don't see any new sunspots form as these groups start to set, we'll see a big drop in the sunspot number and the radio flux. Let's take a look at the last 24 hours in SDO continuum. So yeah, that new group up there, that'll be 3231, I believe. And besides that, most of these groups are largely stable. Again, there's a little bit of umbral migration happening here. And often we do see that. One polarization sunspot typically might rotate a little bit differently than the other one. It'll sort of traverse the solar disk at a different speed than the other one. That's kind of a normal thing. Nothing to really write home about there. And let's get to things like flares and energetic particles. So no spikes in the proton flux, despite all of the flaring and coronal mass ejections and so on. No spikes in the proton flux there. So relativistic particles here remain flatlined. And there is your 3-day GOES X-ray flux. Kind of low here. And yeah, again, we've got some setting sunspots in the west. So the most likely place to see major flares is in the west. And here are some more images. That's 1600 plus 131 angstroms again. Let's drop the 1600. There's the 131 angstroms by itself. And basically, if we are expecting to see major flares, we could most likely expect to see them around that area. Our regular viewers are well aware that sunspots are more likely to be associated with major flares when they are on the limb as opposed to the central part of the solar disk. Here's 94 angstroms. And these custom Helio viewer movies are typically 24 hours unless we tell you otherwise. Keep in mind it does show the time and date stamps in the lower left. All right, so we've got plenty more to cover here. Let's keep things moving. If you're up before dawn, maybe take a moment to look up in the sky. You can see the brightest intrinsically visible object known, actually. Deneb, right there, that star, is the brightest intrinsic object visible from our entire solar system. It's almost like a miniature galactic core in some ways. Did you know that there's a relativistic jet stretching all the way from Deneb to your brain? Yeah. Our solar system is actually partially inside of Deneb's stellar sphere as one of its polar jets. It's a high-mass X-ray binary, and one of the stellar jets is pointed directly at your face right now. Whether you're in orbit around Earth because you're an astronaut or if you're on the surface, Deneb, especially if you're in the northern hemisphere, it's been sending cosmic rays through your brain for your entire lifetime. More about that on the Smash-O forum, and more about the Smash-O forum later in the video. Let's do a solar system forecast first. This is where stuff currently is located. Let's advance it 1 week. As we approach new moon, in 1 week we will be at a crescent waxing moon on the 26th. As February is coming to a close, where did all the time go? And if you enjoy the content, take a moment to press like, subscribe, share, etc. Consider becoming a member of the Smash Team at smashomash.com/Smash Team if you want to send us a couple bucks per month. Increasing the probability these videos will continue to exist, remain publicly visible, and free for all to view. Smashomash.com/Smash Team. Join at the gold or silver level. The best value is the gold annual paid-up subscription, as it includes complimentary merch. It's almost like getting 4 months of gold membership free. And of course, we do include additional content there. We are still also on Patreon. You can find a permanent link to our Discord chat and so on. You can also find a link to the Smash-O forum, the Smash-O merch, the homepage, smashomash.com, and welcome to the Neo-Renaissance. Let's talk about our mission. So our mission at smashomash.com is to assist study and report on the ongoing formation of a unified theory of physics. Also to raise the awareness of the general public of the relationship between space weather and Earth effects. And this mission hasn't changed for about 5 years. It's been written in digital stone. Also to connect and consult with media organizations and multiply our reach, which is an alleged goal of this channel. As far as multiplying, we're lucky if we're able to add to our reach. Demonstrate cutting-edge proof of concept solutions to problems. We grew potatoes indoors over the winter. Were you aware? We didn't really talk about it. To publish scientific papers in a multidisciplinary manner, including but not limited to the sciences listed. To assist mankind by advancing the study of predictive phenomenon. And that's part of the reason why we are adverse to nonsense, because we're only interested in predictive phenomenon, to do things like optimize value, reduce risk and liability, save lives and resources, and adapt no matter what the adversity is, and last but not least, to do actual science. Hence, not be ossified in our beliefs and treat those who are with love, respect, and inclusion to the scientific discussion. So that's our mission. You can read all about it at smashomash.com/forum/mission. You can read all about Deneb at smashomash.com/forum in the Cosmology Forum. There's a thread completely dedicated to the brightest intrinsic object visible from planet Earth. It's practically jumping up and down saying, hey, everybody, look at me, I'm super important. And meanwhile, everybody's looking into different galaxies and looking at quasars 6 billion light years away and being very interested in those, despite the fact that Deneb is an actual cosmic ray point source. Anyway, if you visit the links below the video, you may find our Redbubble shop as one of those links. And I'm currently wearing the hat. It's the Mensa hat, yeah, Mensa, which stands for, Mensa, which stands for Make Earth Not Suck Again. It's up to you. If you've noticed the planet's been sucking the past 3 years, well, a lot of people would tend to agree with you. Anyway, here's our merch in order of best selling. Some of it's pretty fun, some of it's pretty grim, and they make great gifts because reasons. Today's featured product is Smasher Price, My First Pandemic. Congratulations on surviving one. So far, you're doing a fine job looking at the grass from the correct side. In other words, not being dead. By the way, thanks for not pole vaulting the caldera. If you do go on a volcanic vacation, leave your vault pole at home since our finest days lie ahead. Don't worry, folks. Things can get a lot worse. Yeah, things can get a lot worse. The products come in everything from pins to socks to classic mugs. Maybe get yourself a Smasher Price, My First Pandemic shower curtain. What about the acrylic block? That's one of my favorites. You can also get a poster, shirts, how about a mini skirt? Mask up the planet. I'm sure it will be very effective. Of course, I was pretty sure about how effective it would be back in 2020, and guess what? There's a thread all about that subject as well at smashomash.com/forum. It's about 5 months, nearly 6 months, of everyday updates, copy-pasting entire articles about the scamdemic. If you haven't checked that out, you can find that at smashomash.com/forum. Why do I have so many open? What is going on? All right, so let's talk about forecasting. Yeah, forecasting. Because I don't know what is going on with this, but this is absolutely berserk. Most of this CME was on the far side of the sun, which means you should see most of the CME going in this direction. Yet it's modeled mostly going in the earthly direction. So it couldn't be more wrong. There could be a tiny component that sort of like wrapped around and came off in this direction. But most of the CME clearly on the opposite side of the sun. We showed it on the channel the day that it occurred or the day after it occurred. And I don't know what this is. This is just ridiculous. And, note the time and date stamps. The yellow circle here, that's Earth. You've got stereo A here, which is this red diamond. You've got Solo there. You've got Osiris Rex. You've got the Parker Solar Probe. And yeah, I have no idea how this model exists, frankly, because it's completely absurd and ridiculous. And it does not depict reality. I mean, we showed the view from stereo A. You could clearly see that the majority of that coronal mass ejection was the opposite side of the sun. And I don't know, maybe this forecast is what has hack frauds claiming that we're going to get a KP8 very strong geomagnetic storm event from that. It's just not a thing. There's absolutely no way that's going to be correct. And this model is just, I don't know what else to tell you. If you want to look at it yourself, you can find it on the Integrated Space Weather Analysis page. Just click Events, and we actually change the parameter here to dynamic pressure. You can also show velocity or density, but that's not going to change things and make it right in any way. That is a terrible model which does not reflect reality in any way. There could be a tiny earthly directed component on that, but not the entire CME headed in Earth's direction. It just simply isn't the case. It's on the opposite side of the sun, heading away from Earth, not toward it. So let's take a look at some current coronagraphs here since we've looked at the models. This is yesterday's imagery. So additional CME is happening there yesterday. Also not earthly directed, by the way. That one's off to the southeast. That's 95 frames from yesterday. And here are some more frames from today. And there's a CME actually propagating as we're streaming the video. So that one looks like it's off to the southwest. Also does not appear to be earthly directed. So sorry for all of you hoping that civilization ends. First of all, a major solar flare impact, a major coronal mass ejection impact is not going to end civilization in the first place because all the grids aren't going to shut down. Keep in mind, folks, in first world nations, grids have electronics in them to shut themselves down when too much induction occurs. So, I don't know. There's so much nonsense about what will happen if a major CME strike happens on the internet that I just can't cover it all. I just prefer to cover facts, like the location of stereo A. So let's take a look at stereo A here. We'll show stereo A on the left. And there's that CME on the 17th. You see that? Now, I'm going to bring that back, but first, Earth would be off on this line from stereo A's perspective. Let's just go back. If you're looking at the sun from stereo A, Earth would be off to the right. And here's the CME from the 17th. Is the majority of that ejecta headed toward the Earth in any way? Clearly not. There may be a tiny component that's sort of wrapped around that may be headed in the earthly direction, but it's very diffuse. It'll be barely detectable if it does even make it. Because keep in mind, it's chasing a coronal hole high-speed stream as well. So, yeah, and it's going to be of the same polarity. It's going to be like a repeat of the last NOAA forecast. What we like to call on the channel a nothing burger. Now, there might be a small signal from it, but if it happens during a coronal hole high-speed stream, it's going to be the same polarities involved, and I suspect that it'll either miss entirely or be entirely masked and cause no signal to even be detected if that CME ever does make it to Earth. So those are the facts. I keep calling balls and strikes. I could care less if it's scary or if it's comforting. I just don't care because I'm not losing my credibility over anything. Don't cash in your credibility, folks. You'll likely never get it back. Here's the past 24 hours and some spectacular CME light shows happening there, just nothing that'll probably be geo-effective. Here we've zoomed in a little bit further, and that is Saturn down there. And how about an even closer view here? You'll see some of the activity that is associated with those CMEs. But what you won't see is a halo eruption. A halo CME where you see ejecta on all sides of the coronagraph. When you see something like that, that tends to be an earthly directed CME. We ain't got it. We simply don't have that. So I don't know what's going on with the modeling. I mean, granted, it is better to over forecast than under forecast, but this is just absurd. And yeah, so those are the facts. And let's take a look at the filament fest that's going on, because the likelihood of Earth-directed CMEs is incredibly high. Look at the density of this filament up here. There's a little bit of plasma reorientation happening and so on. Let's get a little closer. Some awesome plasma reorientation going on there. We've got huge filaments here. So we will definitely keep you posted if we actually do see an earthly directed CME. But at the time, you can expect only minor impacts, if anything, somewhere between nothing and a dusting. So no major impacts are likely. We've showed you why. Let's show you some more filaments. More massive filaments down here in the southern hemisphere, and I'm losing track. So there are more filaments here than I'm willing to even try to talk about specifically. Incredible imagery there from SDO. That's 193 plus 304 angstroms, by the way. If you want to make your own imagery, that's a great composite set of wavelengths to show your contrast there in the solar corona. All that material suspended by magnetic fields and defying gravity. So check it out. This is the Cerro Tololo ground-based solar observatory. And the sun's not actually pulsating like that. That is interference caused by humidity variations, most likely over Chile. Keep in mind, water emits radiation, and it affects things like telescopes. So this is the 6,562.8 angstroms hydrogen alpha wavelength. And look at all those dark absorption features, especially in the western hemisphere. Massive number of filaments. And of course, you are invited to name filaments. So let me just bring up the latest image here and copy that. And by the way, if you haven't seen the Twitter page. Make sure you check that out. We're all over the internet at Smash-O-Mash. If you do name a filament, you'll have to tell us which one. And you have to do it on Twitter. So you can't do it in the YouTube comments, nothing like that. If you're viewing on BitChute, make sure you view the videos on YouTube, by the way. You're missing most of the content, like our live stream from yesterday. Also, on the Twitter page, you can find a link to the Hemp Lucid free gummies giveaway. Get your free gummies now while supplies last. Let me just bring up the filaments again. So there's the situation. If you've got filaments you'd like to name, just name them after living people via our Twitter account. If you don't have a Twitter account, create one. If you've been banned, sign up under a new email address. It's not that serious. It's just online, quote, social media, end quote, which is about as social as locking yourself in a cave for 20 years. Once again, you can find the link to our free samples there. We've pinned it to the Twitter page. And thanks to everybody who's picked up non-free samples. This is what you'll see if you click that link, as they're giving away free mushroom gummies for sleep, stress, focus, immune boost, and more. So check those out. And if you visit the links below the video, you'll also find our Hemp Lucid shop. Enter the promo code SMASHOMASH10 to save some cash on checkout. You can get your CBDs, your tinctures, your body balms, lip balm, capsules, full spectrum CBD for pets, shop by solution, read testimonials and reviews, and much more thanks to Hemp Lucid. Let's see what's going on the past couple of hours here. We've got some filamentary activity down here in the southeast as well. So huge filament fest going on, exciting stuff happening in terms of space weather. Congratulations on realizing our channel exists. Don't forget to press the like button. Press the share button, leave us a comment, tell your friends and foes about us. If you're an influencer, drop us a line, recommend our channel to your viewers, as we will not be cashing in our credibility for any amount of cash ever. Next, our bonus features segment, checking the satellite's community dashboard for charging hazards, and we don't have any. It's smooth sailing for satellites at the moment. And by the way, Elon Musk, if you're not watching the content, maybe you should, as you just dodged some geomagnetic storms. Of course, now, we didn't forecast those. Maybe you are watching the channel now. Who knows? Oh, you're doing a fine job over there at Twitter, Elon. Just a fine, fine job, pardon the sarcasm. There's the GOES electron flux over the past 3 days, coming up off the floor here after we've watched a coronal hole high-speed stream subside. There's the 1-week chart. And here's the relativistic electron forecast model. No arguments there. There's the 1-year chart to put it in context. That's your relativistic electrons as measured by the GOES 16 and GOES 18 from their geosynchronous orbits. They measure it at the F layer of the ionosphere, which we'll show next. We're going to show one slice, the F layer. It's at about 300 kilometers of altitude. And here's the vibrational frequency and the anomalygram. So we've had a lot of conjecture about predictive capabilities of the ionosphere and so on. As we do stay up to date with these things, we just show the data on this one. I've yet to use it to predict anything. I haven't even been trying to use it to predict anything. And I'm not sure that it's able to be used to predict anything. It is pretty low resolution here. Keep in mind, the resolution of this imagery is only 1 megahertz. The anomalygram is a little bit more precise. There's the anomaly in megahertz from a 30-day median. This does show 1/10 of a megahertz variations. You can see great indications of the location of the South Atlantic anomaly right here. The weakest spot in Earth's magnetic field. Not too far from the equator. Probably associated with deep underground structures like mantle plumes somewhere around the South Atlantic or the South American continent. Anyway, that's what's going on with the ionosphere. There's the latest image, 13:15 Universal Time, coming at you a little late today on our Sunday edition. And there's 13:15 universal time anomalygram that depicts anomaly in megahertz from a 30-day median. We also want to show you the most likely places for GPS errors, so we'll see if the total electron content is back to working. It'll depict the electrons between your GPS satellite and your handset, theoretically. And it looks like this is still down. Press refresh. See if it loads. And it is not loading. So let's move to the Space Weather Enthusiast dashboard here instead, as I believe that shows the US total electron content at least. So there's the total electron content over the US. And things are looking pretty normal there. No major GPS errors that are at least out of the ordinary as we edge closer and closer to spring in the northern hemisphere. Also, we'll show the latest intensitygram and latest colorized SDO magnetogram. That's what's going on in terms of magnetic fields and solar umbrae. Which brings us to our meteorology segment. So as we kept getting closer and closer to Earth, it's time to talk weather. The first thing we're doing here is some wave chasing. Yeah, wave chasing. I find it exciting. I want to know where the world's largest waves are because I want to fly to Tasmania and surf right there. There's probably some killer surf there. And yeah, let us know if you're putting on a wetsuit to do similar things. We've got 43 footers down there in the Southern Ocean south of Tasmania. Those are, I believe, the largest waves in the world right now. This imagery depicts surface winds as well as wave height. So we do have some pretty big ones here also, east of Madagascar. Nearly 40 footers out there. But yeah, the Southern Ocean at the moment features the largest waves. So those are the surface winds and significant wave height. Let's switch to air. There you go. There are the surface winds of the east. Shout out to our viewers from this side of the planet. There are the jet streams of the east. Here are the jet streams of the west. A huge bend there off the coast of Southern California. 180-degree jet stream bend there. And a fairly coherent jet stream over the U.S. and Canada. Surface winds of the western world looking like this. A strong low there, just to the southern portion of Iceland. And here is the surface wind scenario of the central world. And these are the jet streams. If you had to pick only one weather parameter to forecast global weather patterns, the jet stream is highly recommended. On nullschool.net is 250 hectopascal winds signal is what we use for that. Next, we'll show you clouds and fog over the Americas, as we've got great imagery of it here in 3.9 nanometer infrared radiation, part of the NASA GOES Interactive Weather Satellite Suite, depicting Crescent Earth as an oblate spheroid, something that will anger a lot of people. They'll say, have you ever heard of Operation Paperclip? Operation Paperclip proves the world is flat, right? Right? Next, your weather.gov map. If your location is lit, click your location. We've got some winter storm warnings there on the top of Mauna Loa and Mauna Kea. There's the key. If your location is lit, click your location. Head to weather.gov. That's too much information for us to cover, as our viewing area is the whole world. Now, quick thing about snow forecasts, as there are certain channels that don't know anything about atmospheric physics who keep forecasting weather 3 weeks in advance. And the beef I have with this is they have no idea what they're talking about. They probably can't forecast their own weather or know anything about atmospheric physics for whatever reason. So let's just show how ridiculous this is. We typically show 72-hour forecasts on the channel. Look at this forecast. There's your 384-hour forecast. I mean, how many days is that? 384. Seems like a lot of days. There's a reason why we don't forecast 384 hours in advance. So let's 384 divided by 7. Why am I even doing this? All right, anyway, that's all the way through March 7th. And that is too far of a forecast to include. We end our forecast at 3 days. And just so you know, there are a lot of nonsensical thumbnails and people who have no idea what they're talking about in forecasting weather. They rely on models. They don't know anything about physics. And that's why they're shoveling nonsense onto your screens. So here comes some actual forecasts. This is the GFS 72-hour forecast for temperature anomaly in degrees Celsius. Mostly high temperature anomalies here in the portion of the country east of the Rockies, and some mixed temperature anomalies there west of the Rockies. Here is your pressure and precipitation forecast. And it'll be mostly dry here, except for in the northwestern portion of the country. There are some rather heavy snows actually coming to the northern Rockies, portions of California, etc. We'll also show the positive snow depth change in inches for the next 72 hours, as opposed to 384 hours. Let's try this again. 384... not divided by 7, divided by 24. So that's a 16-day forecast. If anybody shows you a 16-day forecast, you can tell them that we said, that's ridiculous. 72-hour forecasts tend to be accurate, or a hell of a lot more accurate than 3-week forecasts. So, yeah. Some heavy snows there coming to Wyoming especially. We'll also show the difference between the Euro and the GFS model. One of the many features of windy.com that you may like. New snow is the layer that we're using here. And there's the GFS model that we just showed you, expecting some more snow in Mexico there. And here's the Euro model. Quite different there. Just a dusting in Mexico. Significant snowfall forecasted in Mexico by the GFS. Just less intrusion to the south on the Euro model, basically. So again, there's the Euro model. There's the GFS model for new snow for the next 3 days. Euro, GFS. Euro, GFS. GFS. Euro. All right, continuing on. To close this thing out, looking at lightning. And it looks like we have no terrestrial strikes in the U.S. over the past about 12 hours. Do we have any lightning on the real-time map? Looks like one strike here. Okay. Maybe that was old data. Anyway, next time you hear thunder, check it out. lightningmaps.org. It's super good. Like smashomash.com. So visit our homepage, help us out with links. If you're unable to open your cobweb-encrusted wallet, or if there's nothing in your cobweb-encrusted wallet, and you're unable to send us a few dollars per month to continue to create these videos and make them publicly visible and free for all to view, visit our homepage, click our links, hit us up on social media, etc., smashomash.com, and welcome to the Neo-Renaissance. Don't forget to press like, subscribe, share, etc. Don't forget to check our community posts, as we put things on the community posts that you won't see otherwise. So make sure you check those out. We put up a video last night about dust. If you haven't checked that one out, check it out. Also check our playlists for videos unrelated to space weather and meteorology. And let's close this thing out with U.S. Doppler radar. So some heavy precipitation there around the Big Island, mainly to its south here at the moment. We'll also show the U.S.'s largest state. Things largely mopping up over there. And how about the lower 48? So that's the U.S. Doppler radar map showing vertical motion of water droplets and ice crystals. Here is your 3.9 nanometer infrared radiation interactive weather satellite map. Lots of low clouds over the Atlantic and the Gulf. Low clouds. You see those? Low clouds, low clouds. Some may say they're associated with cosmic ray flux, as cosmic rays become more and more likely to run into something as they get lower and lower in the denser and denser atmosphere. Anyway, there's water vapor. It looks like clear skies over Kentucky are coming for at least the first half of the day today, followed by some moisture. Here's your recap, the U.S. Doppler radar map. Clouds and fog over a half-dark country. And there is water vapor. And here's me thanking you for tuning into the Smash News Network, least busted name in news. Congratulations on realizing the channel exists. I've been your host, Dan, a.k.a. Smash-O-Mash. Signing off. And may that solar wind be at your back.